Okay, continuing where we left off, we were talking about sig figs and what are the rules of significance. All right, so let's apply the rules of significance to the numbers that we see here. All right, now when those digits are non-zero digits in a measurement, then they are all significant. All right. So here you have 4 and 5, and so 2 sig figs. Again, all non-zero digits are significant. So you have 1, 2, 3, 4, 5. All right, so 5 sig figs. When you have a zero that is kind of in between, wedged in between two non-zero digits, then that zero is significant. So 205 has got 3 sig figs. Okay. Again, here, these zeros are significant. Therefore, 1, 2, 3, and 4 sig figs. When you place a decimal point like so after a zero, then you're making that zero significant. Therefore, the 5 and the 0 are both significant, 2 sig figs. In 25.0, any zero that comes after a non-zero digit after the decimal point is significant. So you have 3 sig figs here. Okay, so you can have as many zeros here after the decimal point and they will all be significant. All right, so 16.00 is got 4 sig figs. Now if this is kind of confusing, sometimes it's okay to write it in the form of a scientific notation. For example, if you have a really large number, all right, writing it this way, you know that significance is only taken with respect to the coefficient and not the exponent, of course. So you have 2 sig figs in 4.8 times 10 power 5. Here you have 3 sig figs, all right. The zero that is coming after the decimal point, after that non-zero digit, is definitely significant. All right, so 3 sig figs. Now these zeros are called as placeholder zeros because they kind of telling you where the decimal point is, but they're not significant. So a number much less than 1, where the zeros are preceding a non-zero digit, those zeros are not significant. All right, so there's only 1 sig fig in this number. Again, here this zero is not significant, neither is this, so there's 2 sig figs. All right, now again, in a large number like this with no visible decimal point, there's an implied decimal point but nothing visible. All right, so again these zeros become placeholder zeros and there's only 2 sig figs, the 8 and the 5. And then here it's 3 sig figs, the 1, 2, and 5. All right, okay. So when one or more zeros in a large number are significant, you can show this by writing that number in scientific. Scientific makes it a lot more clearer. All right, if you want the zero for this number 30 to be significant, you must place a decimal point after the zero. All right, that way this number will give you 2 sig figs. Or you can write this in scientific. You can write it as 3.0 times 10 power 2. All right. In 300. This would be 3.0 times 10 power 1. But if it's 300, you can write this as 3.0 times 10 power 2 in order to give you 2 sig figs. So you can take a number like this without any visible decimal point, which kind of looks like it has only 1 sig fig, but you want to make it into a number which has 2 sig figs. So then you can write this in scientific, and then that way you can have your desired number of sig figs. So zeros at the end of a large standard or decimal number without a visible decimal point are not significant. All right, so if you write this as 4 times 10 power 5, then you know that you have 1 sig fig. All right, the scientific makes it so much clearer about which of those zeros are significant and which are not. Okay. So similarly here, if you write this as 4 times 10 power negative 4, then you'll see that just the 4 is significant. Or if you move that decimal point 1, 2, 3, 4, 5, and then 6, so then 4 times 10 power negative 4.6 times 10 power negative 6, so you have 2 sig figs. Alright, so identify the significant, non-significant zeros in each of the following numbers. Alright, okay. So these zeros are placeholder zeros, therefore this number has 1, 2, 3, and 4 sig figs. This 0 is significant, it's coming after a non-zero digit in a really small number after the decimal point. Alright, so therefore 2, 6, 5, and 0 are significant. Okay, so 4 sig figs. Here there's a 0 kind of wedged in between non-zero digits, so it is significant. So 1, 2, 3, 4, 5 sig figs. Now this is a really large number greater than 1. Again, these are placeholder zeros, so you have 1, 2, 3, and 4 sig figs. Exact numbers are obtained by counting or by definition. Alright, so when you count something, you know that that's what it is. 8 cookies is not 7.99, it's exactly 8. Alright, so either by counting or you can define it. Within the same measuring systems, all equivalents are exact. Alright, so 1 kilogram to 1000 grams, that's exact. 1 quart to 4 cups, that's exact. So within, whether it's American or metric, within it, their own systems, all of those conversions are equalities are exact. Okay, so you have different types of equalities, as you can see here. These are counted numbers, these are measured numbers. However, they're defined equalities, so they're all exact. Alright, so which one is exact, which is measured, and if it's measured, how many sig figs? So sig figs is never with respect to exact, alright, because there's no need to have sig figs with respect to exact. Like I said, exact numbers are exact, alright, whereas you take sig figs with respect to measured numbers. Okay, so 3 coins, this is exact, this is a measured numbers. So here you have 1, 2, 3, 4 sig figs. Now this is a definition, so it's exact. Alright, I'd like you to work on the homework questions 2.1 through 2.6 on page 29, as well as 2.7 through 2.18 on page 32. And that's the end of sections 2.1 and 2.2.